First, I want to mention, so we're going to record this session for those who might not be able to make it, post it online, just to let you know. And I've asked everyone who's signing on just to see where everyone's coming from. If you want to take a minute and just throw where you're signing on from in the chat, we can get a sense for everyone joining us from all over. So my name is Greg Grayson. I'm a Graduate Program Director at the UMass Polymer Science and Engineering Department. And I want to first thank you for showing up this morning and coming here to meet us and learn a little bit about our program. I also, before I begin, really want to thank Lisa Groth, the Graduate Program Manager, and Jen Green, who's working with us here in PSE did a lot of work to bring this program together and help you learn about what we're doing here in PSE. Let's see. So I'm going to give you kind of a quick agenda to begin with of what we're going to do this morning. First, I'm going to give a quick overview, a couple of slides of what the PSE program is, why you should want to apply, a little bit about how you can apply. There's really too much more information to cover than we can cover in this session, but what I'm going to do is try to prime you for things you should want to know about, and we'll be very happy to follow up with email with links to kind of direct you to all that information online, as well as put you in contact with faculty and students who can tell you more. So following that, we'll transition to a panel of students and alumni who can tell you about their experiences in PSE that help give you a glimpse of what it's like to be in the program. At the end, we'll open up the floor to an open Q&A, questions for me, questions for other students, questions for the panel, as well as the staff. As you have questions throughout the program, feel free to add them into the chat. So in particular, during the panel discussion, if you hear a panelist say something awesome and you want to hear more, have a follow-up, just shoot it in the chat. We'll try to catch it and kind of deal with it on the fly. If not, we'll get to it at the end. And so after the Q&A, we'll end the Zoom portion. We'll do that in the hour. And for those of you who have time and interest, we're going to have a coffee hour afterwards. We're going to switch platforms to spatial chat. So you have an opportunity to meet with students, staff, and faculty to ask more questions, maybe following up on some things that came up, or just meet some of us. So, okay, so to begin, so where are we? Who are we? So we're the Polymer Science and Engineering Department here at UMass Amherst. Amherst, Massachusetts is right here in the star. This is Massachusetts, for those of you who are not familiar. Boston, Massachusetts is over here on the Atlantic coast, or about 2 hours west of that, conveniently located, if you like, not too far from Boston and New York City, but in a much more beautiful and affordable place to live. We like to live there. So let me begin with why you consider getting a PhD in Polymer Science and Engineering. And in short, the answer is to be a leader in developing a soft materials-based solution to meet today's societal challenges, okay? And so how do we do that? So we sort of think about polymer science and engineering as sort of a focal point between different sort of traditional disciplines. So on one end of the spectrum here, we have kind of traditional disciplines of chemistry, mechanics, and engineering as sort of inputs to this interdisciplinary soft materials program. And so PhD graduates we train them to be interdisciplinary problem solvers. So they're well-rounded polymer scientists and soft materials scientists and engineers, not simply chemists, engineers, and physicists who happen to work in these fields, okay? And so it's really about bringing these multiple perspectives to the table to sort of develop these interdisciplinary problem-solving solutions. And so what are the impacts of polymer science and engineering? Well, of course, there's the sort of discoveries and research in polymer science and engineering drives knowledge discovery in a range of academic disciplines, both in natural sciences and engineering. But I would say most importantly, these are the sort of challenges that we need to overcome to address society's kind of some of the biggest problems. So things from sustainable resources, climate change, health and medicine, and transformation of manufacturing. And so how do we do that? Part of how we do that is through research, training through research. And these are kind of a way we think about the research frontiers in polymer science and soft materials as carried out in the program as it stands, kind of loosely lumped together in these three areas. So polymers, materials and for sustainable resources and energy. So these are things like battery materials, more recently, polymer upcycling, polymer circularity, materials for life or lifelike materials. So on one hand, that's flexible electronics, personalized medicine, polymer therapeutics, but also things like bio-inspired materials, where you're trying to learn from living organisms how materials can be made in sustainable ways, right? And to achieve new types of functions. And then last, we have a quite active area in innovation for next generation advanced manufacturing. And so we don't have enough time to tell you everything that we'd love to tell you about research. The best way to start to learn about this, I'm going to send you here to these lab videos. Our different group members, the faculty members, as well as the students, will tell you a little bit about what they're doing. You can follow up on websites, but again, please reach out to us if there's somebody you would like to hear from, some particular areas you're really interested in learning on. We're very happy to set up interactions with folks. So this research, I'll emphasize, this is something that's really important to our students, is kind of at the center of it is world-class facilities, kind of the suite of materials characterization and high-performance computing tools. There's really too many that I can list here. What I want to emphasize is that not only are these materials all available, but they're really at your fingertips. So basically, almost all of these are within the building of Polymer Science and Engineering. And so, this is really the foundation for the cutting-edge research that we do here in the department. So who are we in Polymer Science and Engineering? So this is a snapshot here on the left of the incoming class here in fall 2021. Something that you should know about us, and that's probably unique to probably most of the other graduate programs you might consider applying to, is that PSE is a graduate-only program. So that means that we're sort of entirely focused, our educational mission is entirely focused on graduate PhD program. We're 17 full-time faculty. A typical class size is sort of 12 to 18 students. I mentioned that our mission is kind of pursuing knowledge at the intersection of polymers and soft materials. This is an example, sort of a snapshot from our mission statement on the front page, or you can link to it from the front page of PSE. We recognize that this requires us to bring together faculty, students, staff, and scholars from diverse perspectives, backgrounds, cultures, disciplines, really bringing those experiences and that common community together to address these challenges is sort of a core to our mission. And that starts with the kind of disciplinary backgrounds that folks in our program apply from. So this is the pie chart of the most populous undergraduate degree programs PSE applicants come from. You'll see materials, chemistry and chemical engineering, physics, actually a relatively small number coming from a specific degree program with polymers in its name. Okay, so really we're bringing folks from a broad interdisciplinary background to this graduate work. And if you don't see your program on this pie chart, we nevertheless really welcome you to consider applying. We love to think about or hear from students from aerospace, engineering, applied mathematics, wherever you're coming from. We want to know how and why you're interested in graduate research and education in soft materials and polymers. So who are we demographically? This is just a snapshot here on the left on our student demographics, broken down into percent female graduate students among the population, percentage of students from underrepresented and minority backgrounds, percentage of international students. Here, PSE, our program is in blue. Two comparison programs are shown in red and green. These are material science programs in the US. I believe these numbers, at least for PSE, are a 10-year average or so. So you'll see off the bat that our female to male ratio, as well as the international domestic, statistics are fairly well balanced. The underrepresented minority students here, while we're slightly better than the national average, we recognize the number of underrepresented minority students in our field is too low. And that's something that we here in Polymer Science and Engineering and at UMass are committed to continue to work forward to address, right? So what does that mean? That means that we have a number of programs and initiatives across, including in the department and across the university, that are sort of focused on fostering inclusion and success for students from every background. And I can't go through that, but I'd love to talk to anyone who wants to know more about any particular facet of this. Much more to say. So what does it cost and what's it like to live as a PSE student? I'll just give you a couple of top line numbers here. The current stipend for an incoming student is going to be greater than $30,500. This is the take home money that you get with annual increases. Just to highlight, you might hear numbers from other programs that incorporate other costs like tuition, insurance, and benefits. We pay those as well, but this is the number that you will get paid, right? You will not have to pay these costs. And so what you need to know is that all PSE students, if you're accepted into the program, you're going to be fully supported throughout your whole PhD process. And TAing is not a requirement, right? There's no TA requirement, and this is something, again, unique about having a graduate-only, graduate-focused program. There are opportunities for TAing, so many of our students want to gain experience and training in TAing, and like I said, I could tell you more about that. And how should you think about this number? You can go ahead and take this and plug this into a cost of living app and compare it to the different programs in different places you might live. What you'll see is that the Amherst area is, it's quite lovely. It's quite bucolic area, nice place to live, and the cost of living is relatively low, right? So typical rents are in the range of $800 to $1,000 a month or something like that. Again, this is something I encourage you to talk to our students about. So what is the timeline for a PSE student? I'm going to quickly walk you through this just so you get a big picture. So in the first semester, we begin really all PSE students are focused on core classes in physics, engineering, and chemistry. This is 5 classes, including 2 labs. It's a pretty heavy course load. And what's important to notice is that there's no TA-ship during this period. Your job is to really become, develop a common knowledge and a foundation for polymers and soft materials, and your stipend is supported by the department through generous support provided by industrial sponsors, as well as our alumni, who really are committed to the kind of educational mission that we provide here in Polymer Science and Engineering. And so in that first semester, you're really developing that common framework, and you begin to find your PhD advisors. That's to say, you don't have an advisor before you come in. In fact, no students no students will have an advisor before they come in. The advisor selection process starts after you meet and discuss with students from different labs and advisors in mid-November. So right about now, our first year students are thinking very hard about what research groups they want to join. In the second semester, you have a slightly reduced course load, 4 classes, but you're still focused on core courses. You begin a cumulative exam process. The cumulative exams, there's 6 exams. You have to pass 3 of them. They begin in February of the second semester and are every 2 months. I want to emphasize that these exams they're not a mechanism to weed PSE students out. If we admit you to the program, we want you to succeed and graduate with a PhD, right? So we have a very high success rate in these exams, and that's why you have multiple attempts to not get it right the first time, right? That's what graduate school is about. You don't have to get it right the first time. You learn how working together to improve where you can. And in that second semester, you begin to on-ramp into your PhD research in your research group. Into your second year, then you've completed cumulative exams, we're already finished, and you start to develop your research proposal sometime around the end of your second year, ideally. Into your third year, there is an additional milestone to advance to candidacy called the independent research proposal. This is where you propose a research project that you're not necessarily going to work on, but it gives you an opportunity to sort of train and develop how you think about and talk about and frame research before you do it, something that essentially every PSE graduate is going to have to do in their life. So this is an example of the additional type of training that you get even beyond the coursework and research. And beyond your third year, you conduct research and you finish your PhD, you find a job, and you get rich and famous. So just a quick numbers on that. The average time to degree in PSE is just under 5 years, and comparing that to other programs and the national average, you'll see that time is pretty good. That we link in large part to the fact that there's no TA requirement and that you're supported by the department in this first semester rather. And the percentage completion to PSE is again about 90%. So if you're admitted into the program, we want you to, and we're going to work very hard to make you reach that PhD degree. So certainly lots of folks want to know about careers that are opened up by the PSE graduate degree. This is just a pie chart of the sort of top 3 areas that graduates get hired into after they finish their degree, largely in industry as well as academia, and a smaller number in national labs. But this is not an exclusive pie chart. Really, we have graduates who kind of work in all areas of society. Here's just one of our heroes, Dr. Katie Coleman, who after finishing her PhD went to go fly on several NASA missions and do science in space, right? Which is that's the coolest thing. This is just again kind of a spectrum of many different companies and national labs and federal agencies that our alumni work for. So what I want to emphasize here is a few things. Basically, everybody who leaves PSE has a job, right? That's top line. And why is that? Well, we have active recruiting in the PSE program. So companies come to our department, into our building, and they want to talk to you, right? And they meet with you actually well before you are applying for jobs. And so this is just an example of the companies that have come to recruit in PSE in fall 2021 so far, right? And so this sort of access to companies who are looking for your skills it really is very impactful in the success rate of job searches for our students. So those that recruiting is complemented by mentoring and job search and interviewing through our industrial consortium and a large alumni network going back over 5 decades. All of this, again, results in the fact that not only will you have a job, you will likely have multiple job offers, and that will give you the opportunity for competitive starting offers. And really the opportunity not just to take your first job, but maybe to move to other jobs, right? And have the job of your choice. So let me now say a few things about applying to the PSE program. These are the kind of key ingredients, well, actually the top 4 are the key ingredients of the application process. So first, what do you need? You need to submit a resume that summarizes your academic credentials and achievements. What we look at very carefully is your personal statement. And the personal statement, which I have to emphasize, should not just be a summary of what is written on your resume, right? Don't just walk us through your resume. Your resume already lists those achievements. What we want to hear is, why is graduate school important to you? What is your story that brings you to consider applying to graduate school in soft materials and engineering? In particular, if you've had life events or challenges that you've had to overcome that you think speak to how you want to approach graduate school, why you're going to be successful, tell us about those, right? Those are the experiences that, are not going to be reflected in transcripts, maybe not even in resume items, right? So we want to hear, really, what is it about you and that brings you to this program. We're also going to request 3 letters of reference. So these are usually from instructors in your classes. What I want to emphasize is you should make sure to think about people who really know you, right? So not just the instructor who taught a class that you got an A in, right? In a big class of 300 people, they don't know who anyone is. But somebody who has at least some interaction with you and can tell us a little bit about why you will be successful, right? So perhaps you've taken a course that you had to struggle and work a little bit harder than you thought you would, and you have a faculty member who can tell you a little bit, tell us a little bit more about how you overcame those challenges. You'll need to submit your official transcripts from your undergraduate programs. We're going to look most carefully at the grades in your core courses in your undergraduate major. Grades in mathematical coursework is also helpful. What do I want to say? The GRE. What I want to emphasize here is GRE is not required for applicants to the next year's program. If you've taken the GRE and you want to submit your scores, you're welcome to, but they're not required. Overall, what I would encourage you those of you thinking about how your transcripts and scores reflect on your application credentials, I would refer you to this really nice story written by one of our alumni, Daniel Acevedo. It says it's about beyond the GRE, but it's really more about kind of a holistic approach to thinking about applying in strengths for graduate research programs. So given those ingredients, the review of the applications is done by myself, plus likely 2 or 3 faculty. We are an interdisciplinary program, and so not every student is going to have a background that's compatible with my own expertise and theoretical soft matter physics. And so, I'm certainly going to be turning to my colleagues to give additional input. Okay, so before we end here with the panel, I just want to give a kind of a brief snapshot. I want to encourage you to, if you're going to stick around, to talk to our students who have so much to say about the awesome kind of culture and community that they create. This is, I can't say enough about sort of what sort of a strength to the program, the climate that the kind of students create. There are a number of groups and clubs and initiatives that have been, proposed, developed, and led by the students throughout the years. One of those that I like to highlight are the outreach and aspire programs. These are programs where graduate students themselves take their training and go out to K through 12 schools and in the area and beyond, and really try to inspire the next generation of STEM students. And so it's always inspiring to me to see the graduate students kind of growing into leaders and educators themselves. Okay, so with that, I'm going to now transition to our panel. We're fortunate today to have 3 panelists. I'm going to quickly introduce them, and as I said, feel free as the panel is going on to shoot some questions into the chat. If we can catch them, we'll try to thread them in. But otherwise, we'll have an open Q&A at the end. I think everybody is on here, so I'll just begin. So our panel this morning is going to have 3 folks. Nolan Miller has undergraduate degree in material science and engineering from Purdue University, West Lafayette. Finished in 2020 and joined us last year. Ria Ghosh has undergraduate degrees from University of Calcutta and joined PSE in 2017. And Dr. Marcus Cole recently graduated, had undergraduate degrees in chemistry from University of South Carolina, and joined in 2014. So I'm going to unshare my screen and we'll get started there. Okay. So just to begin with, I'm going to ask the panelists to just take a quick second or so to introduce yourselves, tell us just sort of where you're from and how you got to the PSE programs. And Marcus, you can tell us where you are now. So we'll start, I guess let's start with Nolan.
Hello, everyone. I'm Nolan. So yeah, as Greg mentioned, I did my undergraduate at Materials Science, or at Purdue University Material Science and Engineering. I'm originally from Minnesota, but what drew me to PSE is that I've always been interested in nature and how that kind of connects to science, and that's a really big component of the PSE program. And so I learned a lot about that in my senior year of my undergraduate, and so that's what kind of connected me with the science that we were doing here, and that really sparked my interest.
I'm gonna go next. So I'm Ria. Hi, I'm from West Bengal, the state in India. I did my undergrad in chemistry, and then I did my post-bachelor's master's degree in polymer science. I had 3 months of industrial internship experience in a plastic composite industry, but then in my final year of my master's, I did research in one of the lab there on semiconductor polymers. And while doing that research, I got an idea that in which direction I want to pursue my future. I talked to my master's advisor who suggested me a few universities where I can look into for PhD. And then from there, I got into this field and chose this university.
Thanks. Marcus.
Sure. Yeah, so I'm Marcus Cole. I got a bachelor's degree in chemistry back in 2014 from the University of South Carolina. While I was there, I worked for Dr. Brian Bentwitz. He was like my research advisor, and he introduced me to polymer chemistry, doing a lot of controlled radical polymerizations, ATRP and RAFT. But rather than just making stuff in lab and kind of not knowing what to do with it, it was really applied. We were making different kinds of core share nanoparticles that we wanted to use for delivery systems for therapeutics, some quantum dots for electronic and imaging applications. And I got kind of caught the polymer science bug because I saw the applications that you could kind of go down with this technology. And Brian was like, well, if you want to go deeper and see if you can do the physics and the engineering and not just the chemistry, then you should go to UMass. And so I applied and got in, and kind of I can talk more about what happened after that with follow-up questions. Oh yeah, well, and now I'm in Oakland, California, working for a company called E-Ink.
Cool.
Yeah.
Okay. So maybe now we'll go background the way we came. Maybe just tell us about what kind of research you're doing. And so Marcus, you can tell us what you're doing now, but also tell us what you did when you were in PSE.
Cool. Yeah, so right now I'm a synthetic polymer chemist for a company called so we make low energy electrophoretic reflective displays. So you probably have seen these in, if you own a Kindle that's been made in the last decade, that's some E-Ink film in there. If you go to department stores with a lot of electronic shelf labels, especially those that have full color, those are more than likely E-Ink displays. So I predominantly work in our internal phase division, where I help modify some of the colloids that go into our laminate, develop new polymeric and small molecule additives that can help with image quality or processing quality. And then also I still get to do like some fundamental research where I kind of get to make funky particles that don't necessarily have an application now, but maybe we could do something interesting with them later on. While I was at PSE, I was also in the electronic materials space. I worked in Dr. Todd Emmerich's group. And while I was there, I predominantly worked on interfacial materials for organic photovoltaic devices, different kinds of polymers and small molecules that can tune energy levels in the photovoltaic stack, or particularly modify like the electrode active layer interface to drive charge injection. So I've been pretty electronics, and I did a brief stint at Clorox for about 1.5 years when I first moved to California. But for the most part, I've been an electronics guy since getting my PhD.
Cool, thanks. Ria, how about tell us about what you're working on?
Yeah, so my work is based on, I'm working on water filtration membrane using different approach. Like I'm using an amphiphilic zwitterionic block copolymer system, where I'm using the zwitterionic block as the pathway through water, and also to filter out any impurities like salt or like miscible solids in the water present. And what my approach is that instead of using pore size or a porous membrane for filtration purposes, I'm trying to use the self-assembly structure of these block copolymers using their morphology as a pathway for transportation of the water molecules or the filtration of the salt molecules. So yeah, okay. This is my work.
Perfect, thank you. Nolan?
Yeah, so my research is a bit of a combination between buckling mechanics. I'm looking at a lot of snap-through buckling mechanics mixed with some chemical vapor deposition chemistry and physics. And the thing that I think is really cool about this is that it all kind of ties back to some multidisciplinary research done in biology on things like mantis shrimp or Venus flytraps, trap-jaw ants. And it's all about understanding how energy and stored elastic systems can be harnessed and controlled and then rapidly released for powerful actuators.
Okay, so I think this gives a quick snapshot of the real kind of breadth of things that are going on here and kind of where that takes you. There's much more to say about that, but we'll go ahead and move on. So we've taken some of the questions that you sent when you registered and tried to fold them into some prompts that we're going to ask the panelists. Again, if something sparks your interest, just shoot it in the chat as we're going, and we'll try to fold it in. And so we'll go ahead and start. So a bunch of folks are interested in general advice about the application process, and I'm going to throw this question to Ria first. If you might share with us some bit of advice you wish that somebody had told you before applying and starting in PSE. Oh, you're muted still. It looks.
Yeah. So
yeah, sorry.
When I applied to PSE, I had like a very narrow focus on what I wanted to work with. Like I was working in semiconductor in my master's as I talked, and then I came here just thinking, oh, semiconductor will be my field of research, until I came here, and then I realized polymer science can be such a huge field, and it has so many different aspects to reach out to. So I would suggest that if someone is looking for a PhD or a program to join, make sure that you apply for a program where you see yourself working with different people, where you can reach out to different people from different background, different focus. And yeah, don't have your thoughts very narrow. Like, don't think like, I have to work on this, I have to work with this particular professors. You don't have to. You have too many options. You can choose, like, keep your focus area a little bit broader. That would be my suggestion.
Any other panelists want to jump in on that or follow up?
Yeah, sure. The only thing I'd add would be, and this is probably very specific to my experience applying. Sure. As an undergrad, I was still very self-conscious about my writing and my applications. And so I didn't want to show all of my documents to as many people as possible, which, I mean, like I was still able to get into the program, so it was fine. But as I'm writing my thesis later on, I realized all of the really good edits I could get if I just share my work with as many people as possible and get as much feedback, and like not taking it personally and like assuming that like I'm a bad writer or I can't produce work. It's just the more people that can see and give feedback, the better your applications, your personal statements, your fellowship proposals will just be if more people can look at them and give you different kinds of feedback. So that's one recommendation I have.
Great advice. Okay, why don't we, we'll move on to our next area. So we had lots of questions about how to start, what's it like to start life in PSE, and Nolan, you had one of the unique experiences, unique years of starting life in PSE, and I'm going to throw it to you if you tell us a little bit about just what's your experience, and again, what's that, how in this first year, and how do you connect, how have you connected with other students?
Unique experience is an understatement. But I think that it provided a good insight into how unique that can be, but also how dependable the PSE community is at giving you that reliable entry year and kind of integrating you in. And so, yeah, for my first year, there was a lot of differences in like your coursework. It's all online, right? But still, the things that were held consistent was, first year groups were still meeting virtually to help each other with homework. People were still, finding ways to have office hours to, get through the questions in courses and homework with professors and stuff. So the first year, it's you're learning. It's a lot of coursework, but I think it's also a year where you're building a lot of kind of community with your peers, but then also just with the PSE department as a whole. So I would say your first year is summed up with a lot of coursework education, but also just integration into the community here.
Any other follow-ups about? So I'm going to just two follow-ups I would add is, so Nolan is making reference to the fact that last year was a COVID year where classes were online and labs were online. It's particularly challenging. Where for those of you who are interested, we're back to in-person classes and labs here in PSE. But I think it speaks to, as he's saying, the community for the kind of resources that the connections provide. Any other stories to share there? If not, we can move on to learning about how you found your research group. So I'm going to throw this to Marcus. I don't know this story, so I'm wondering if you could tell us about how you found and how you found your research group, and how did you figure out your PhD project, or how did that happen?
Yeah, so I guess my initial approach to kind of finding my advisor was probably similar to most students. Before I got to PSE, maybe the summer, I'd started looking at different professors, papers and their groups. I think I shot a couple emails to existing students just to say hey, could I talk to you about what it's like to work for your advisor, your project maybe, just to get kind of some early knowledge, because I knew once I got here it'd be busy and I'd be having these meetings, but I wanted to try to get as much ahead as I could. And then once I got here, I think I met with almost everybody, but I was definitely already leaning towards electronic materials. It was something I knew I was passionate about for the environmental impacts, but also I'm a comic book nerd, and the idea of working with electricity and chemistry is kind of textbook if you want to get powers eventually. So that was kind of where I was leaning, and Todd's charisma really helped solidify that I wanted to join his group. And his first question was well, so what are you going to do? And that took a couple of months of me just reading more papers and figuring out how am I going to impact electronic materials as a new person. And I kind of settled on the project through multiple discussions with Todd, some failed synthetic reactions that I was okay, this is never going to work, so let's try something different. But yeah, it was kind of an amalgamation of all these things that kind of settled me on interfacial materials for OPVs.
Cool, that's good stuff.
Yeah.
Right. So Zaria, if you came in with a different, you wanted to work, maybe you can tell us about how you.
Yes, for me, I think it was more of I wanted to join a group where I would find myself more easy to communicate with my colleagues, with my advisor. That was my main focus. And some of my group members I already connected when I was still back in India. So after I came here, they helped me a lot. Also, some of the groups' previous project aligned with my new ideas or new interest, which I started to grow after I joined this department. Then I reached out to Brian, and I definitely found what I was looking for: easy to communicate with advisor. Yeah, for me, that was the main point of joining this research group.
So, okay, well, I'd like to hear more as well from Nolan, but I maybe kind of pivot to a related question. If Nolan can say a little bit, about doing work in a collaborative team, and Nolan in particular works across multiple research groups, which is one of the experiences that many PSE students have, and maybe you can put that in the context of how you defined how you found that research group and what your experience has been like.
Yeah, I think the short answer is opportunity. So my background was in material science, and the groups that I'm working in have a lot of focus in mechanics and physics. But as my research, I mentioned that it's bio-inspired, and so a lot of it I can also connect with biologists. So there's so many opportunities for reaching out to people that are in different fields than you and having those kind of collaborative projects, but also just internally with different professors working in different fields. It's very easy for you to kind of collect that information from both and then synthesize completely different items out of it. It really comes down to just opportunity for whatever you're interested in going towards or extracting information from. Those resources are really available for that.
Cool. So we're running short on time, so I'm gonna just try to hit two more key questions that we've got. So I mentioned a little bit in the slides about experiences in PSE and what's PSE life outside of classes and outside of the lab, and I'm gonna throw it to Ria to share something about experiences or knowledge or skills gained outside of the classroom, outside of the lab, if you have any to share.
For outside of lab, I know that when I first joined this department, I don't know whether I improved or not, but I was really bad in communicating with other people. So I think to rectify that, I did join some of the groups. As Greg mentioned previously, I was a part of mentoring committee whose job was to help the newcoming students to transition into this department life. I got a lot of help from my previous mentor who kind of inspired me to be a mentor. I joined that, where I got to contact with newcoming students who would have lots of questions. Then I also volunteered to be a TA for first year student in the synthesis lab, where I get to teach students who already know this field more about how life looks like inside a lab. And some other thing which I did volunteer was Aspire group, where I had to teach or show some of the experiments to the high school students. There, I think I learned how to communicate science with students who does not have any idea what's going on in this field. So spark interest to people in their language in our field, like in the STEM division. So these are the things I think I volunteered to do to develop my communicating skills. So.
Cool. If anyone else wants to jump in there, welcome. We have just a few more minutes.
Sure.
Go ahead, Marcus.
I definitely think I probably spent more time in lab, but a large amount of my time doing polymers science or polymers all around us outreach, which is a really amazing program that the department offers. You get to go to K through 12 schools, sometimes community colleges, annually the Boston Museum of Science, and get to share with the non-science community all of the interesting things that you can do with polymer science, really cool and easily accessible hands-on experiments that are great for younger people, older people, people without a technical background. And spending a lot of time in that space just really helps you learn how to communicate your science to non-scientists, which if you end up working in industry is going to be like a part of your day-to-day job. Like not everybody understands like kinetics of free radical polymerizations or potential like unwinding or unzipping mechanisms of polymers. So like you need to be able to explain things to people that have never taken like a PSE 602 class or something. And so spending time in polymers all around us like really kind of gives you that language and that foundation to have those conversations and still like exchange knowledge without having to like use all of like the traditional like jargon and dialogue.
Cool. So we're just about to finish up our panel here, and the last two questions are really targeted towards life after PSE. So I'm gonna toss those to you, Marcus, because I think you have the most direct experience here. Maybe just a quick one. What's it like to apply for jobs, and what was it like for you anyway? Applying for jobs in PSE, right? I mean,
yeah. It was both nerve-wracking and really fun. So because you don't know if you're gonna get the actual like even on-site offer, and so kind of going through like the multiple iterations of getting your resume right and practicing interviewing with like your peers and giving all of like your practice talks like amongst like people at PSE to get ready. And then like once you do the application and you actually hear back and you get some nice responses, it is fun to kind of go on the on-sites if you have the opportunity to, because you get to see the cities you might be living in, interact with like your future colleagues, get to see like probably like for the first time in like the last 5 years, like what industrial research looks like right now, and some of the projects that are actively ongoing. So it's definitely like nerve-wracking because you're like trying to finish this, probably the biggest thing you've ever personally done, which is your PhD, and then simultaneously trying to completely like shift your life to a new area, a new job, and things like that. But luckily, like everybody at PSE is great, and you have great support systems. So even though it is this high stress, like emotionally charged experience, like you have people that you can reach out to get support. You've got a great alumni community that can kind of give you insights and help you navigate through the process. So it was good, but it definitely is a big deal as you go about doing it.
Big deal. Cool.
Yeah.
Well, so with that, I guess, why don't we, if you have, I think you mentioned a little bit about this, but just as a closing statement, since you've been outside and had 2 jobs already, right? Maybe you can just share one thing about your experiences and training or the PSE community that's kind of impacted you, that maybe surprised you, I guess, or not.
Yeah, it surprised me how quick, like if I said I was from like UMass, and they would immediately kind of go to like, oh, you're a polymer guy, or like your person, and then you would immediately just get thrown on projects. And I guess like more of an anecdotal thing, while I was still at Clorox, I joined the company. Some subject matter expert heard I was from the Polymer Science Department, and they were like, we need to send you to Germany for this conference so that you can evaluate these materials because we don't have anybody with that background. And I had barely gotten through my security training yet. So it was just kind of like the fact that I have this knowledge that's allowed me to kind of navigate multiple jobs very recently, but even like right out of grad school, the reputation of the department and the skill sets that people understand that people with that degree have really kind of allowed me to have a great onboarding experience and early career experience with like my first company. And it's allowed me to pretty much seamlessly transition into a new job that really wanted me because of my polymer science and engineering background. So I feel like the degree kind of speaks for itself. It's very useful from a job perspective.
good. Well, with that, thank you, Marcus, and thanks to all of our panelists for a great discussion. And I hope that gave the number of you joining in some ideas of what it will be like, it might be like as a PSE student. And so with that, I'm just going to open the floor up to, I'm going to put my screen back up. Just to open the floor up for other questions in the audience. Either you can drop them in the chat. I can't see the chat right now, so somebody will have to read it out. Either responding to either questions for the panelists, questions for me. Also, if you are would rather discuss questions one-on-one, we'll have the coffee hour afterwards, and you're welcome to come and find one of us to discuss. Let me see if I can pull the chat up. I see one question in the chat, and there's one question about applying to 2 separate programs in UMass, and the answer is yes, you can do it. There's a question about paying the application fee. What's relevant here is that if you've registered and attended today, the PSE will waive your application fee. So as you are applying, and we'll pass this material on to you in an email to follow up, for the application fee, you're supposed to click the box for check, and then PSE will pay that, but we can deal with that after the fact. There was a question again about how much is the stipend per year. The stipend you take home is will be greater than $30,500 a year, and the average cost of living. Well, the number in terms of the rent I quoted for you is about $800 to $1,000 per month. But that depends a lot on sort of what type of living arrangement you want to do. If you want to share a room or you want your own place. And again, I'd suggest you talk to students more for context about that. And there's a question about coming to visit next week, and we can follow up about that for somebody who might be in the area. We can follow up about that. Any other questions? You can also feel free to unmute yourself and shout out. Reka is entering in the chat that she'll be at ASHE as well. I think at least one of my group members will. So we'll make sure to get your coordinates. If there are other questions, you should feel free. There's a general email, psegraduate@umass.edu. Lots of logistical questions. Feel free to direct to, Lisa Groth or myself. We'll shoot you a bunch of links with all sorts of information to help you find it more quickly. And I think at that point, if there aren't other questions, we're going to go ahead and I'm going to ask Jen Green to jump in here and tell us about jumping over to spatial chat for the coffee hour.
All right, great. Thanks, Greg. So for everybody that would like to meet us in the informal gathering space of Spatial Town, where you'll be able to ask more questions, more in a small group environment, we're going to use spatial chat for that. I have just put a link in the chat for getting there. And for those that are unfamiliar, what happens is when you first click on the link, you'll be asked to put your name. It'd be great if you type in your name and where you're from. Next, it will ask you if you want to allow your microphone and video camera to work. That would be great if you would, so that way we can communicate with you. On the bottom left, you'll see a little bit of what it will look like. In order for you to move around through the space, you're going to click and drag on your avatar.
Sorry.
Is that you, Greg? Okay.
Yeah.
Okay.
Sorry.
And if you look at the top right, the first room that you'll actually enter is called the reception room. You'll see a poster that will talk about what's going to happen in the other room. I will actually be in the reception room if you have any logistical issues getting to the next space. And when you do get to the next space, you can choose one of 3 posters or move between them. One is about applying to the program, one is transitioning into the program, and one is succeeding while you're there. There'll be people from the department standing by each one, and if you get near them, you will be able to talk to them